Welcome back to the CTO Playbook, the podcast dedicated to helping CTOs excel. In this episode, I'm speaking to Maxim Fateev, CTO and co-founder of Temporal, about the future of backend development. Maxim shares how durable execution is revolutionizing event-driven architectures, making it easier for developers to build scalable, resilient systems without the complexity of traditional distributed computing. If you want to understand why software engineers at companies like Stripe, Datadog, and Snapchat rely on Temporal, and how it could change the way your teams build software, then stay tuned. I'm your host, Adam Horner. As a coach for CTOs from startups to enterprises, I empower tech leaders to escape the cycle of lurching from crisis to crisis and build the skills to lead with confidence, clarity, and purpose. Max, welcome to the CTO Playbook. It's great to have you here. Of course, you've got a great background being somebody who's been leading the charge in distributed computing for quite a while. But for those of the listeners who are not that familiar with you, Max, it'd be great to just get an idea of who you are and where you've come from.
Currently, I'm CTO and co-founder of Temporal. Temporal is an open source project and a platform which we built at Uber initially. So we probably can spend more time talking about that later today. And before that, I worked mostly for large companies. I spent 8.5 years at Amazon, 4 years at Google, 4 years at Uber, a couple of years at Microsoft, and some telecom startup before that. And when I came in 98, I started to work on big AT&T in New Jersey. That was like original AT&T from like Bell Labs days.
Right.
And so I worked on the interactive voice response platform there, but not for very long.
Right. Okay. So no stranger to distributed computing then at all.
Yeah, I practically started there because that AT&T platform was practically a large distributed system.
Excellent. Okay. And what were some of the sort of challenges that you faced then early in those process of building distributed systems that led you to where you are today?
I think most of my real experience with like large scale systems, designing and building them and operating them came from Amazon. When I joined Amazon in 2002, it was a relatively large company by then, but it had only 800 developers. So by current rates, it's not that large. Wasn't that large. And Amazon was practically built as a monolith. Certainly it was running a lot of instances of that monolith, but at some point it just became unbearable to maintain that. Just to give you some idea, just to compile that, like full clean build of that monolith was 18 hours on a practically high-end machine. And as a developer, just if you do any change, you had to relink that binary. It was obviously C++ binary. And that relinking process was taking up to 45 minutes. So imagine you change a function signature and you have to relink, and then it takes 45 minutes. And anyone who kind of used to the TypeScript or Python, when you just change code and magically appears, certainly was very hard to work with. So they had to go to microservices and these large-scale systems.
Yeah, very much the opposite of responsive coding when you're waiting that long for a simple linking and a full compile. Yeah, you wouldn't do that very often, would you at all?
Yep. And then I kind of came to the platform team. It was called Splat Software Platform. It was well before Amazon AWS was even conceived.
Right.
And I ended up in the what we called frameworks and applications group. So we owned PubSub and different frameworks. So first I kind of built Java framework for Amazon backend services. And later I switched to PubSub. And we built a distributed sub-broker-based architecture system. I kind of helped design and implemented first version of the resilient dedicated storage for that. Later, that storage was adopted by the simple queue service at Amazon. Again, I didn't talk to the team.
SQS is actually built on top of that then?
It was built. I don't know where it is right now. I didn't talk to them for like the last 5 years, but it was running for a very long time on that architecture. And one thing is I was practically tech lead for the whole kind of PubSub of Amazon for a while. And practically every new use case, every new service which was using PubSub was kind of going through me and talking to me and to our team as well. And we quickly realized that just event-driven architectures are very awesome at runtime because they allow you to disconnect services and allow you to have systems which don't melt down if single service goes wrong, like something goes wrong. But at the same time, they're extremely hard to program and extremely hard to maintain just because they practically, one way kind of to talk about that, sometimes I mention that you can think events as being global variables of distributed systems. right? Because you publish event, you change event format, you have no clue what application will be broken, right? So they create very, very tightly coupled systems, which is interesting because some people kind of get confused by that because they hear that event-driven systems are loosely coupled. Reality is that loosely coupled and runtime, right? So one component will not affect others, but in design time, they're extremely highly coupled.
Because you've got to understand the data structures of all the elements on each end of any of those messages in order to be able to understand it. Yeah.
Once I've heard a different conversation there is that somebody says, no, but you can add new service and this service doesn't need to notify any other services that is consuming those messages. But you can make the same argument about global variables, right? Because you can say, I can add new module which will read all global variables and nothing should change. But the where it ends up. Yeah, so then we practically had to think about how to change that. And we started to think about practically workflow engine initially and orchestrator. And the result of that work, it was actually multiple iterations of work, was a simple workflow service at Amazon. And a simple workflow service introduced a lot of new concepts, but it didn't completely solve developer experience. So we had some good ideas there, but it certainly never became successful service there. I think Amazon doesn't even promote it right now. Besides, it still exists there. If you search for Amazon simple workflow service, you will find it. I think step functions run on top of the engine of simple workflow, but they don't expose
But they've abstracted away quite a lot of the underlying work that's in there. So step functions are something sort of an evolution on from there, aren't they, really? Which is also, did you have any hand in step functions, or is that just something that has evolved in the same manner?
It happened after me. My personal opinion is not evolution, it's actually step backwards, but
really, okay.
We can talk about that. But yeah, because the idea of practically, what is distribute, type of problems that step functions solve, or the type of workflow engines or whatever. You practically just want to make sure that some computation completes, right? There's not much to that. You call a bunch of APIs, you want to make sure that all these APIs complete in the presence of failure. And then if you are just using something like normal language, usually you cannot do that because if you just write a function which calls three APIs A, B, and C, and then calls B and crashes in the middle, you lost your state, right? So then bad things happen. So people start practically breaking that function in a bunch of pieces. They put queues in the middle, right? They put databases, and your code becomes a mess. So instead of three functions, you write hundreds of lines of code. You introduce external dependencies and race conditions. And most of the systems these days are event-driven, and they actually usually huge messes. And the solution proposed step functions is, okay, you cannot really write code which is durable, so let's just come up with some code in YAML, right, or JSON, I don't know what they use. And you can draw a picture with that. But reality is what you're trying to do, you're practically trying to take something like Java and convert it to JSON. And it kind of works for very simple use cases, but the moment you kind of go to complex use cases, you need to do asynchronous events, you do your complexity just keeps growing, right? There is a reason we don't write Linux kernels or other kernels in in JSON and YAML. Because programming languages, they're created to deal with complexity, right? They just...
And recovery.
We have systems with millions of lines of code in C and C++ and Java and Go, but nobody will say, okay, let's come up with, a DAG-based language in YAML and rewrite everything like that. But that was the only option. So practically what we introduced is the idea of what we call durable execution. We said, okay, what if you can just take normal code, in a top-level programming language, and just make it durable? So preserve the full state of the code. So if you have a function which calls ABC, we guarantee that this function will never crash. So if even process crashes, machine crashes, we will move it with exactly the full state. So if it's blocked on B, it still will be blocked on B. We move it to another machine, or even passivate, and then reply to B comes 3 days later, we will reactivate that, and your code will execute to the next line of code, to C. So practically we just preserve full state of the execution. We call it durable execution.
And it's line-by-line state saving then, isn't it?
Yes.
And that as an engine then, if somebody's going to try and implement that themselves, that's going to be a fairly significant amount of essentially boilerplate engine work to do that if they wanted to do that. So obviously building on top of a framework that provides that, it's the only way forward to have this idea of durable execution then.
Yeah, doing it yourself. Okay, you practically will build the framework solution but the reality is that it's not easy. And you can probably, this is interesting, durable execution is an abstraction. It's like transaction is an abstraction, right?
Yeah.
And there are millions of databases supporting transactions. How many databases do we use in production? 5, right? 10. but it's very, very limited number, right? The same thing here. Durable execution as an abstraction, you probably can implement it. It's not super complicated, like on a basic level. But the moment you say, okay, I want a production-worthy system which scales and can provide all these guarantees, certainly there is much smaller club of companies which can support that right now.
Yeah.
And practically the Temporal is an open source project. It's MIT licensed, so just make sure that everyone can use it. There are a lot of companies using it for free. And it's fully featured open source. It's not kind of open core model, no. It is fully featured open source project, so you can use it. And at the same time, the way we monetize that, we run the backend component of that. So there is a backend cluster which keeps the state, and then we can run this cluster for you and charge for consumption. That is how the company monetizes that. But it also means that we guarantee compatibility of your application if it runs using cloud infrastructure or your infrastructure. And the other part which is important is that the way the security model is done, that you run the code. So this durable execution, this application runs on your premises. It's part of your application. It's just a library which you link into your code base. And then it just needs the backend server to keep the state, the same way as you need database connection from your application.
Right. Okay. So basically, if you were to run it yourself from the open source, then you'd be running essentially a service which is hopefully going to be resilient as well, that handles the state management for you, and then the rest of it is just using the open source libraries in order to guarantee that state maintenance through execution.
Yeah, and then if you need to switch to cloud, you just change the connection string, but you still run the application the same way. And then you also encrypt everything before sending to the cloud. That's why big companies use cloud a lot, just because it's very secure. They never send anything in clear text.
Yeah, so it's very convenient, it's very secure, and fault tolerant. I mean, so the idea of this here is that you could lose, as you said, almost an entire data center and carry on running from the next line of code effectively.
Not almost. You can lose the entire data center because we support multi-region replication. So it means that you can lose the full region and your application can continue in another region without practice downtime.
And across another cloud even.
Yes, I think I don't know if we support failovers already across clouds, but we absolutely going to do that very soon.
It seems like a relatively simple step from there to go from one cloud to another than it does from one instance to
it's
another.
It's mostly connectivity. It's very hard to, you practically need to pay for fiber to do private link between clouds, right?
Yeah. Okay. Right. Yeah. There aren't that many companies that need to do that right now. Cool.
If you go over open internet, it's easy. So
yeah. And so then, therefore, Temporal becomes a very flexible way of running a very fault-tolerant application. It's entirely, the other thing is it's entirely event-driven. So you've got to be starting from the point of view of an event-driven architecture, right?
It is internally. This is like the beauty of Temporal, that you get all the runtime benefits of event-driven. So internally, it's all queue-based, it's event-driven, right? So you get all the components are independent, so they can go independently. Your application can be down, but some other part of the application can be up, and things will pile up in the queue. So like you get backlog. So it's usual behavior of asynchronous systems, but it's all runtime. And design time, you just write normal code. You just call function foo, right? Or and then this foo can be executed in different machine and take 5 hours. And you still will, like 5 days or 5 months, you still will be blocked on that foo in that line of code. So it makes programming these distributed systems as easy as normal like RPC-based systems, and with all retries and durability taken care of for you. So imagine a situation when, like, if you look how event-driven systems are done, that people say, oh, if you're doing ordering, you will have order service. If you limit events, some other service will pick up that event. And then, okay, what's going on in my system? I don't know. I have a bunch of events everywhere flying around. And here you can just write it practically one function which will execute the whole order, right? Do this, do this, do this, do this, do this, like, I don't know, and ship. But the ship takes 3 days, fine. It will be blocked on that line of code for 3 days, and it's normal.
So you don't have to worry at all about the normal sort of capacity worries, because the fact that it's fully asynchronous and can stop at any point, therefore you're not worried about this much capacity for that service and that much capacity for this other service. It all runs anywhere there's an agent able to run it then, and completely flexible, so more flexible than most architectures are around where your actual compute is then.
Yes, it is. It's just obviously you need to think about capacity, especially if you don't want these workflows take too long, right? But reality is that it can accommodate any capacity, and it just and again, if you didn't provision it correctly, you will get a backlog, and then you will just deal with this backlog. And obviously, right now, based on backlog, you can auto-scale your worker fleet, practically fleet of your processes, so you can just deal with those situations as they arrive.
So it's going to handle, sort of spiking performance quite nicely. So, Max, most of the platforms that I've worked on have been relatively small. I mean, you were talking there about, Amazon and Uber and some of these companies you've worked for where they've got, massive problems with huge scale because of the fact they've got so many users of those platforms. But, if I'm working with a company and they're building a small app for, tens to hundreds of users, is this approach still relevant? Does it scale down to that size?
Yes, because think about it, there are two absolutely orthogonal things. How well the system scales, and then the developer experience itself. And if you think about how much code you say, but practical question is, do you need reliability and guarantees? If you don't care about them, then you probably don't need this system. Just do everything in memory in one process.
Right.
But the moment you say, okay, I need to guarantee that this computation, business transaction, whatever will complete. And again, by business, it can be anything. Because business transaction can be deployment, can be provision new infrastructure, right? So there are all sorts of use cases around that as well. If you need guarantees, this is just much better way to write those applications. So you will save a lot of time writing them. So it increases your developer productivity. And it sounds weird, but I've heard it from multiple customers and users of the platform is that they get 5 to 10 times productivity gain. Not like 5%, not 50%, not even 100%. They say 5 to 10 sometimes. Because they practically don't need to spend time dealing with all these issues of event-driven systems, and they need to build their own platform around that. So they just focus on their business logic. We've seen cases when companies said, oh, we needed to add this feature, and business didn't want to ask us because they didn't know if we would be able to ship it for Q4, and they were in Q3 or something, and they shipped it in a day. And they said this was only possible because they're using Temporal, because it was actually a few lines of kind of code which they put into the durable execution instead of just trying to practically engineer the full complex system for that, which would be required otherwise. So it allows the companies move much faster. So if you're a small startup and you're using that, you're losing a lot of time building, practically doing undifferentiated stuff.
Yeah.
The way you can think about it is, imagine before databases didn't exist. So people would write and read files, right? And now if you're saying I'm going to do business application and I'm not going to use files, but I'm not going to use SQL database, okay, a NoSQL database, right? Like Mongo, but people will say you're crazy. But I think we are kind of introduced this new middleware component, which people, once people learn about it, they cannot unknown it. Where, okay, I cannot just build my system without this. The biggest driver of adoption of the project, and it's been going 5 to 7% month over month for the last 4 years since we started to track that, was people moving around the companies. Almost everyone who learned it in one company, once they move to another place or talk to their friends, they just bring it with them. They cannot just go back to the old ways.
So it's very much a word of mouth growth and an experience-driven growth. Is there a change of sort of paradigm or concept takes time to get to grips with, or is that something whereby it's straight drop-in?
It's a change of paradigm. This is where I think most of the, not complexity, but you need to start thinking about the problem differently. And unfortunately, it's not taught at schools yet. At least I think it's in some, it does, but I think it's very rare. And these people are not learning these concepts, so they need to relearn. You practically need to relearn how you do. Because you, for example, go to the on-site and say, okay, this is your job interview. How would you design this, order processing, or the timer service or whatever. And then there is the whole kind of whiteboard of components, right? Like architecture, how to do that. And they're like, okay, but you can just write 50 lines of code and you just get what you want. I actually had a real story that I have a friend and he's in IT and he said, oh, I want to learn this cloud computing. So he came to me and brought a book about what written for one big cloud computer provider, and practically it had a sample. A sample was something like, oh, I want to once an hour get all top tweets in my feed and just analyze them somehow and just post an email with a summary or something like that. Pretty simple. And then it was this fancy architecture on the first chapter explaining how to do that. Oh, here's the cloud function. This cloud function calls on database, puts it in cloud queue. This cloud queue is doing this. And it was 15 components to produce that. And I'm like, okay, sit here. And I sit with him and I wrote the whole code end to end as a single workflow in probably 20 minutes in Java, end to end. Obviously, I didn't implement all the kind of actions, but like the whole logic of that thing fit on practically one page on my IDE. And he looked at the chart. The whole book was about that. And he's like, okay, where's the catch?
Yeah. So the full abstraction, it changes the way you think about architecture, changes the way you think about actual operation and maintenance as well, I imagine.
Exactly. It's because you have just one place to look at your business logic, and your business logic, it is not broken into 500 pieces living in different places. And mostly, actually, one of the analogies I gave at one of my talks was practically think about architecture, like we want a layered architecture, right? But usually what happens with current architectures, we take all this, like this cake and put in a blender and we blend it, right? Because reality is there is no single place when you, for example, care about durability. There is no single place when you care about retries. There is no single place when you care about crashes. Everything is intermixed, right? So you probably get this like blended architecture, like for practically smoothie architecture, right? And instead of cake architecture. And with durable execution, you actually can separate out business logic from the rest of the kind of complexity. And this is exactly what Temporal is. It allows to move most of the complexity of distributed system into the platform. And then you as a developer don't need to deal with that directly. You just think about your application.
So then you can sort of rely on the predicates in the core platform. So, I mean, it sounds like magic, right? You can just, start using Temporal and you fix a lot of your infrastructure worries and everything goes away. But are there any scenarios where you wouldn't apply this, where you wouldn't think about this?
So there are some runtime limitations which you need to think about. And also, first question always asked, do you need durability and guarantees? If you say, yes, I need guarantee that some process will complete, it's almost always a good fit. Sometimes it requires some engineering. For example, it's not a big data crunching platform. So it's not going to reduce MapReduce and replace MapReduce. It's not going to replace Hadoop. But for example, it certainly replaces a lot of other orchestration frameworks, like which practically try to orchestrate these pipelines, like pipelines. That is a lot of those are replaced, right? So, but you're not going to like send terabytes of data directly through the platform because it's more like orchestrator platform, but it's not the big data platform.
So not a pipeline then.
But pipelines. Again, pipeline is probably a bad word. Pipeline is, I think, is kind of. Because think about what is pipeline. Pipeline is not sequence of steps. Pipeline is more like streaming pipeline. Like you have files in, there are stages and there is data flowing through them, even if it is a big files or individual messages. And controlling those pipelines and orchestrating those pipelines, certainly you can do with Temporal, and it's a very common use case. CI/CD is kind of like that as well. There are tons and tons of CI/CD systems written using Temporal. For example, Netflix switched from Spinnaker. They first wrote Spinnaker on top of Temporal. Now I think they're tossing Spinnaker completely and just using Temporal directly to write their, orchestrate the infrastructure.
Got it. Okay. And so when it comes to, putting in place durable execution, where is that going next? What's going to be the next sort of iteration of durable execution from here?
So I think there are different ways to move it forward. Certainly right now, we integrate with all major languages. We have 6 or 7 SDK. 7 right now, I don't know. But all major languages, we just added Ruby. I think the only one which is still missing is Rust. People beg us to add Rust, but otherwise I think all major languages are covered. We will add it at some point. And runtimes of those languages are not as easy to. Ideally, you would have some sort of container which will allow this thing to run and recover. And we are doing it in JavaScript because we're using V8 isolates. So practically we use that. But in other languages, we don't have runtime support for that. So we practically need to sometimes say developers, okay, there are certain rules you have to obey to integrate with this framework. And it's not as good. So ideally, in the future, something like WebAssembly becomes powerful enough to run every language efficiently, or maybe some other way to do that. But immediate term, I think it's mostly about adding more features to the core platform. It's not durable execution per se. It's more about, okay, what can more complexity of distributed system can we move into the platform? For example, we just added priority queues, right? So it means that you invoke some operation, now you can prioritize, put priorities there. So we are working on the fairness support. So practically because a lot of companies build multi-tenant solutions on top of Temporal. So if you're building SaaS service, you can use it to practically orchestrate backend jobs or even interactive jobs because it's performant enough to do actually real-time stuff. So you can do if a user clicks something and waits for reply, instant payment, or also to other similar scenarios, you can absolutely use Temporal. A lot of companies build multi-tenant services on top of Temporal. So practically, if you have your own SaaS offering, it's multi-tenant, you have your own clients, and you need fairness and priorities across them. So we want to support them natively. So you can go and say, okay, I have 100,000 clients, but not a single client can trump all other clients, right? Practically create noisy neighbor problem within your clients. So we want to support those type of things directly. We're investing more in reliability. For example, we launched all the features about multi-region replication. So even full outage of a region or like complete meltdown, even a cloud provider wouldn't bring down your application. So availability is a very important part of that. And another interesting concept which came from that is Project Nexus. What is Nexus? As I described, you either have RPC right now, or the moment your request can take longer than a few seconds. Okay, if it's LLM, it can take a minute, but the reality is that we still don't want a long RPCs. And you practically have to go event-driven. There's no other way right now. And we asked the question, why we cannot have RPC, which can be long-running? Why we just cannot say, okay, this is a service, it exposes a bunch of RPC practically handlers, but every handler can take 3 days if necessary. And it obviously it integrates with things like durable execution very nicely, because you can just call this operation and block on that. The same way your durable execution can implement any operation. It can be as long running as you want. But at the same time, it doesn't need to be only about Temporal. You can absolutely start integrating other systems. Why you cannot call step function as such operation, or step function invoke other technology through something like Nexus? And these days, we're talking about tools. We are talking about LLMs, right? Why right now MCP doesn't support tool which runs 3 days? But if you plug MCP into the Nexus, for example, you can absolutely start doing things like that. You can absolutely have a tool which runs as long as necessary, and Nexus will provide guarantees that this will complete, or you will get a response at time. And obviously, it's also cancelable. So the idea is that you can start practically thinking about not only about implementing one single application and one single service, you can start thinking about linking all your practically enterprise services through Nexus, and it will give you much, much better visibility and experience that, for example, just shipping events around. And internally, you can actually implement Nexus Gateway to events as well. So if you're using Kafka to ship events and request responses, you can plug into the Nexus and create high-level abstraction on top of that. So it absolutely should nicely integrate with all the existing systems. It's not replacing for them. It's just elevating level of abstraction when we're building those type of systems.
Right. So you can call your API and not worry about whether it's going to return imminently or whether it's going to take a long time to come back. So it's basically fully distributed across API boundaries then.
Yeah, and obviously there are interesting technical details because, for example, if request takes 3 days, when reply comes, the process which made the request will not be there, right? Possibly. So it means that the underlying infrastructure needs to understand that the request came, correlate the request, load the state, right? Being able to process that. With durable execution, it's all seamless. From your point of view, it's just a block and call, which goes to the next line of code. But you absolutely can implement it any other way. You can have practically a handler which says, okay, this is my request ID, load from database my state, and perform some function. So it's pretty generic protocol. So we absolutely recommend checking it out.
Yeah. That sounds awesome. And so, in terms of getting started with Temporal, for those people who've sort of not really come across it and not encountered it previously, what would you recommend as the way to get going with Temporal as sort of the first thing to do?
I think just go to temporal.io, click on documentation, or there is learn.temporal.io, and you can take courses. We have 101, 102, 103 courses in major languages, and you will learn it pretty fast. We have a bunch of examples for every SDK. We have getting started. It's an open source project, as I said, it's MIT licensed. And we provide local development environment, practically single binary. So you do brew install Temporal if you're on Mac, and then you get Temporal start dev, and it starts the whole service with the UI and everything included. And then you can start practically connecting to that, writing code, running samples. And it takes 5 minutes practically to start running samples and being able to play with that. So and then because it is a little different way to think about that, you probably want to take a course. If you just read this code without understanding how these things is composed together, how the execution really happens, you get confused if something goes wrong.
Right. Okay. So familiarize yourself with the paradigm as well as going through the samples. That's a good tip. So, Max, I'm also interested in your role because you're CTO of Temporal, but not in a sort of traditional sense.
I don't know what traditional is really, because every company, I think, it's different. Just to give you some history, I actually was CEO of the company for a while, 4 years. And at some point, company grew to the point, and I'm, okay, just stepping back. Both me and co-founder of Temporal, Samar, we were engineers all our lives. We didn't manage a single person before starting the company, ever.
Right.
So we always tech leads. I was tech lead at Amazon on multiple projects. Samar was tech lead at Microsoft. He led Azure Service Bus, and he built durable task framework, which Azure durable functions run on that. It's kind of similar idea of uses durable execution. And then at Uber, we both were leading these various projects. And then we started the company. We practically had to do management. And I became CEO, he became CTO. And he was traditional CTO. He at some point ran engineering and product and a bunch of other functions.
So he was more familiar with leading people than you were then?
I was leading less people, probably the whole company, because I was CEO of the company. But at the same time, I kind of realized that it's not my thing. I just like technology a lot. I like kind of going to the code, doing design, kind of talking to customers, and just hiring the next executive is just not something I enjoy doing, and dealing with all the other issues. And then as company grows, right now we're 250 people, problems change, right? So it's all about marketing, sales, and go to market and so on. So there are a lot of things which I just didn't enjoy doing. And I just decided to step down and kind of switch places with Samar. And he's much better dealing, I think, with those. Nice thing is that it wasn't kind of because people think, oh, somebody forced you. Like, company was doing great. We were growing. Like, nobody will ask CEO to step down when everything goes up. I just felt that was the right thing for me and for the company. And as I had a co-founder, I trusted 100%. So it was actually easy choice because I had somebody who could do it better, and I trust.
Absolutely.
So, and he's a co-founder as well, so he has all the same stakes in the company.
And I think it's a very empowering move to be able to sort of define the role that you know you're going to be best at within an organization. I think some CTOs default to this idea that, I'm an executive, I must now run everybody within engineering and everybody report through me, and I must deal with all the challenges as they come up. Whereas I think if I've understood it right, what you've done is sort of carved out the role where you actually perform best and deliver best, but without having a lot of people reporting to you and having to do.
I have 0 people reporting to me now.
So you're pretty much doing R&D then. So you're sort of doing the research of sort of the next areas and next development. Is that how it works?
Practically. It's not only, obviously, I'm more like chief architect, kind of. Right. And also I certainly do the kind of more forward-looking stuff. Right now, I certainly spending time in the AI space much more, because we kind of unexpectedly ended up being an AI company, in the sense that we don't have single AI product, but I wouldn't be surprised that we are actually the most used company for AI workloads in production by enterprises. Because if you think about it, all these AI workloads are technically just workflows.
Yeah.
I think people still don't realize that, because everybody's tinkering on their desktop. But the moment you say, I want to put this agent or this AI inference pipeline or whatever application in production, or the first question is, okay, how do you know that this thing will complete? How do you know that it will sustain failures? How do you know it will scale? How do you get visibility to what's going on, right? How do you get all the enterprise features around permissions and so on and so on? And the moment you realize that, you're practically building an orchestration engine, right? You're practically trying to rebuild Temporal. And practically, it's kind of interesting to see the industry, because everybody tries to reinvent workflow engines right now again. So we practically started from step function type things, right? Or like BPMN type things. And probably more and more people, especially people who already know about Temporal, they realize that durable execution is just much a better way to write workflows. And all agentic stuff are workflows. Everyone tries to kind of reinvent that wheel of workflow engines, because if you think about, at least the way I see the progression, is that the first frameworks were all about in memory. It's practically orchestration of calls, which technically just a bunch of API calls. And there is this movement asking, why do we need a framework if all you need is just call 5 functions? And obviously there are common data structures, and you need to do some optimizations there. But reality is that they're good to start, but you kind of hit the wall pretty fast with features and adjustments you want to do. So a lot of people say just write code. But the problem is that the moment you write code, you kind of, okay, and now I need to make it durable. I need to guarantee that I'm not going to lose my state. If I'm doing research, for example, research can take 20, 30 minutes. I'm not, and every call is very, very expensive. I'm not the one to lose like everything if my machine crashes in the middle, especially if you're doing enterprise settings for a lot of customers. And then you're, okay, how do I do that? And I don't know how, but like reality is we are trying to reinvent the kind of workflows. Oh, we will do that. We will do kind of some sort of snapshotting. We will do whatever. And now you have to use framework because otherwise you practically reinventing step functions, right? Because you need to have this YAML or whatever or objects which will kind of link it together. And when you think about, okay, but if there is durable execution already exists. Well, if you need to orchestrate calls, and especially super dynamic calls because it's just code, right? It's very easy to write an agent. It's just simple loop. Call LLM, gets list of tools, call LLM. It's like 30 lines of code. And that is, I think, where we are right now. It's kind of interesting. I think slowly started to realize that it's not just, it's orchestration problem. And people who know Temporal come to us and say, we already running AI agents, we are running AI applications top of you, we are doing inference pipelines. And I think right now what we are trying to do is just go out and talk to people, maybe build some lightweight framework as well. But reality is that, again, framework doesn't have that much value. Value isn't durable execution. And I think more and more people realize that right now.
And so therefore, that durable execution piece is becoming sort of the backbone of agentic workflows then. Even though it's not something you specifically wrote it for, it just happens to solve the use case rather well.
That is exactly what's happening. And I'm not super, actually, it was something which we kind of knew that it is, but I think right now we're getting so much adoption and so much interest from users and clients. And we just, if you go temporal.io/AI, there is a link to like small demo and videos, and we are doing webinars about that. But it's mostly education at this point. It's practically just, look, you don't need to trust us, just go and prototype yourself and see how it works, get our kind of samples. And my feeling is that I heard from users, customers, that they're practically saying, you use frameworks to prototype and kind of tinker with that, but the moment you need to go to production, you need something like Temporal underneath.
Yeah, because I think when you're doing in small samples, small things, it doesn't matter if you lose your step, your way, but as soon as you lose a step when you're calling an LLM, that the price can go up if you're sort of setting yourself back several steps, having saved the progress so far, especially since it's effectively stateless when you call the LLMs. You just provide the new context, run the next step, but the context is everything. The state's important. The actual execution engine, where it is and how it is and so on, not so much. I went to a conference recently where they were going through where AI is going in general. And it does seem to be this sort of complex distributed network of agents with the output of one going into the input of another, or in some cases going into an intermediary decision-based system before then going on to another agent. And that sort of stringing together of agents, if you don't save state in between those calls, you're going to be potentially losing quite a lot of expenditure in that time. So it seems like an absolutely ideal workflow.
Exactly. And I think what you see kind of the same thing as the rest of the industry, right? Because now you hear is that, now you need a database to preserve the state, and everybody reinvents how to save state. And then, you need event-driven systems. You kind of see a lot of people say, no, you need to do agents are asynchronous, so you need to do event-driven system between. And then it's exactly the same problem as any other event-driven system. You will kind of end up with very complicated setup, which is actually very hard to troubleshoot. And practically at this point, people who know durable execution, they realize this is the perfect fit for that. And we certainly are very lucky because we've got certainly very significant bump in users and customers just because of AI workloads.
Do you think it was luck, or do you think it's sort of the natural evolution of the way workflows are going and how steps in workflows just generally get more abstracted and therefore more expensive to recreate if you lose a step?
I think it's just, let's say this way, it's a general paradigm, right? Durable execution general paradigm can apply to almost anything.
Yeah.
But at the same time, we see this movement of people going to the cloud-based architectures, right? So far, like last years, a lot of this was about migration to the cloud or migration to the cloud-native architectures, which usually means microservices, more moving parts. The moment you have more moving parts and need to have state across them and you need to orchestrate them, then we saw a lot of adoption there. And my understanding that agents and LLMs, all they do is that there will be many more moving parts, because instead of one person, we'll have thousands of agents right now, and we will do many more calls and need to orchestrate many more calls. So conceptually, it didn't change. As I said, people can reinvent in workflow engines since a long time ago, and we are trying to apply the same concepts or reinventing the same concepts for agents. But reality is that at the end, we will have services, agents, components which talk to each other, and they are unreliable. The requests can take a long time. They need to preserve state for a long time because they can react to external events, right? Because it's not just, oh, I do research for 20 minutes. It can be my agent lives forever and reacts to whatever event which came in, right? Like practically it's all about state management. It's about orchestration. It's about preservation of API calls and so on.
Looking at it from the other perspective then, so when somebody is actually, using AI or using, assistance low-code tools to be able to write code, a lot of that is predicated on being able to write on simpler but more abstracted blocks of utility code underneath that. Do you think then that Temporal provides an ideal framework foundation on top of which to write code because there's less of the mechanics and boilerplate of making the code run that makes it more ideal to AI workflows for actually doing the development?
Yes, absolutely. And we've seen multiple people already doing that. And some of them are very amazing, practically built all amazing platforms on top of that. Because it's exactly the point, is that LLMs are good enough right now to generate business logic. So if you ask LLM, I need to do, marketing. And my marketing is send email, wait for reply, send email in 3 days, do whatever, and you describe that. It can generate you that business logic, code for that business logic perfectly. The moment you say, okay, now this code needs to survive any failure, preserve state in database, and scale to million parallel flows, then AI it's not ready for these type of things. That's why durable execution is a perfect target generation platform. And I've seen all incarnations of that. I've seen just people obviously using tools like Cursor just to write their workflow code in IDEs, but I also seen people doing full-blown platforms. Then they practically run this generated code in line, and they dynamically load that, and they have practically agents writing agents, and all of that is fully dynamic, and kind of this durable execution is the biggest part of the whole thing.
So it's a good foundation for being able to write well-abstracted business logic code then, which is ideal because I think a lot of the AI LLM approaches allow a very straightforward linear kind of generation of anything, whether it's language or code or, as you say, marketing steps. But as soon as you need to do something that's multi-tier, that requires complex logic, that's where the very definition of an LLM kind of gets lost.
But most business logic are not complex. If you think about it, business logic is usually not that complex, at least for LLM to handle, right? It is making that logic robust and durable and fault tolerant and so on, and scalable.
Yeah. Excellent. Max, obviously our main audience is CTOs, tech leaders. If you had to give one piece of advice to our CTOs who are listening, about where you think the industry is going, about what they can do as one of their next most important steps, what would that be?
I'll stay in my small part of the world. Is that if you don't know about durable execution, please give it to your engineers. If you're technical, play with it yourself. And just at least understand this potential of this technology. Again, because all our adoption was always bottoms up. And the way we usually talk to high-level kind of executives about that is not the school and it allows to write less code and so on. It's just developer productivity. I mentioned that is that some people report 5 to 10 times increase. So, and I know that people care about developer productivity a lot at this level. And so if you do care about developer productivity, you do care about reliability of your systems, you do care about kind of uptime, scale, and also keeping your developers happy, just at least look at the durable execution, look at Temporal, and then make your own opinion about that. And you can always talk to us. And we have, I don't know how many right now, probably 15,000 plus people in our Slack channel. Slack workspace, just go temporal.io/Slack, join our workspace. I'm always there, so you can find me there. It's the best way to contact me directly. Just DM me there, and we can go kind of discuss any use case. And as I said, also people at this level usually care about security. I promise you, the moment we explain you and talk to your security people, they will say it's okay to use even our cloud product because we have, by design, very good security model.
Yeah, I guess when you started working for the cloud providers, you know exactly all the objections and challenges that people throw at it. So starting off from the point of view of that knowledge, it's a pretty good place to build something that's tolerant to those objections. Thank you. Maxim, it's been wonderful to speak to you. Thanks so much for your time today. And I hope everybody else has enjoyed the enlightenment you brought to it as well. Thank you very much for listening all the way through to the end. Just before you go, I'd like to ask you for one thing in return for putting together all these episodes of the CTO Playbook podcast for you. Please leave a review. Wherever you're listening, whether that is Apple Podcasts or Spotify or whichever platform you're on, leaving a quick review will help more CTOs find the podcast and enable me to create more great episodes. Thank you for listening, and I'll see you on the next episode of the CTO Playbook.